Hey everyone, I'm Philipp. I think I'm here for the third time in a row, so thanks for that. Let's see what we can do today. Today I want to talk about a bit the monitoring side of stuff. So I want to talk about metrics, pings, traces, all the things you want to do in your application. So let's see how we can get started. Kind of the initial idea for this talk was that tweet, where somebody said like, yeah, as soon as you have this distributed system, every outage is kind of like a murder mystery because you're searching for stuff going wrong here and there, and you're just running around and you're not really sure what is going on. And unless you want to be Sherlock Holmes and you want to search for problems on your systems, it can be kind of a pain. And we want to take that pain away and see how we can improve that logging and monitoring of the system. So generally, as soon as you have an application, probably that is what you have. And how you feel, like it's all fine, it's kind of burning, but it's all fine until it is not anymore. So at some point you then figure out like, no, this is not fine anymore. And we kind of want to avoid that point before we get to that thing where we figure out that everything is crap and nothing works anymore. So this is where we kind of want to go. And for example, Sam Newman, he's very well known in the microservice ecosystem. He always says like, the stuff you need to have is you need to have like some aggregated or centralized logging. So you need to kind of see in one place what is going on your system. And then you probably want to correlate traces or calls to your system to see how they're behaving. So that is kind of what we want to do. Overall, it's kind of like logging and monitoring all the things. And we'll dive into that with a demo. So this is all online, and I hope this works. And you can actually generate the requests for that system. So we'll dive into that. Let's see how it goes. Why am I even talking about that? I work for Elastic, the company behind Elasticsearch, Logstash, Cubana, Beats. I'm part of our infrastructure team, so I'm a bit more on the ops side, though I do my share of development as well. So we do stuff like running services internally, Docker containers, AWS, and we need to log and monitor a lot of stuff as well. And then I always say that thing in the middle is a Unix pipe. I kind of pipe that out into developer advocacy, so I talk a lot about the stuff that we do and build. And I always say, like, I kind of build highly monitored Hello World applications. So while this is a Hello World application, I try to keep it as real as possible, so we're using proper certificates, and we're doing all the right stuff. So we have multiple instances here which are running, and which we can just call and get some requests and see what is working and what is not working. Just before we get started, how do you log and monitor? Anybody still using SSH and tail? Anybody? OK, that's a few. You've kind of come to the right talk. We want to get rid of that tailing and SSHing, which is fine as long as you have one system. But as soon as you have more than 3 or 5 servers, SSHing becomes kind of painful, and you don't really want to go there anymore. So if you want to run these examples yourself, it's all on GitHub. I frequently push updates and try to update it and see how it goes. You can run all of that yourself on the cloud. So I've built a very small application. I'm using Spring Boot, Java. It doesn't really matter. It's just like some application. It's throwing some exceptions. It's getting you some real outputs. So it's just any random application. You could put whatever other Java application or PHP or Python or whatever under it. I'm mainly focused on the monitoring part here. So the application doesn't matter that much. And I try to keep it simple. So I'm not doing any auto-discovery, load balancing, whatever. I kindly or mainly follow that microservices is, if it's called, has very short names. That is a totally valid excuse if somebody asks you, are you doing microservices? And you can probably say yes, because we have very short names for stuff. That is also a very microservice. And of course, it's running in the cloud. So I'm using the cheap AWS instances, which are the Lightsail ones. I automate everything with Terraform and provision and deploy with Ansible. You can ask questions about that, though we probably don't have enough time to dive into the details on that side. You can either check the code or ask me afterwards. But that's kind of how everything is set up. And we have our own cloud service. That is where I'm storing all my data and how I visualize it. So we have Elasticsearch and Kibana on our own service. I'm just using that in the background. Or you could just take the same stuff and run it locally. I have been told that you need to mention Docker in every talk nowadays. So I have done that now, so you can run it on Docker as well if you want to do it locally, but we'll run it on the cloud and hopefully everything works out. And it's all open source, so all the stuff I'm talking about now is open source. You can run it yourself, you can run it on any cloud account you have, you can run it on-premise. It's Apache 2 license, no strings attached, basically. So this is our stack, which I will use to monitor the stuff. I will not really use Logstash because I don't really need it. So I will use the beats, which are like lightweight agents or forwarders or shippers or whatever you want to call them. They will collect some information. They will store that information into Elasticsearch. And then we use Cubana to visualize what is actually going on. That is kind of the logging and monitoring and tracing side. So let's get started. Let's ditch the slides and let's do something live. So I have my application. You can actually call it, it's called Xiera WTF. Anybody knows where my nickname Xiera is coming from? Any guesses? We didn't really mention it, but my last name, Krenn, if you do a rot 13 on that, so if you rotate the letters by 13, like if you forward them by 13, that is how you get to that. And the nice thing about rot 13 is if you rotate by 13 again, you get the original back. And it was kind of all the rage in the Usenet times where you would encrypt, like, I don't know, the spoiler of a movie, rot 13, so nobody could read it accidentally. Or if you wanted to provide some illegal software, you would just name or change the name by rotating the letters of 13. And only people who knew would know what to search for. So that's what I'm using on the internet. You can find me under that on GitHub, Twitter, or wherever. And since this is a demo, I thought WTF is kind of the right domain name to use for that. So if you call that, you will get this page. And by the way, you can totally do that yourself as well. So anybody who has a phone or laptop out, you can just call that. We're collecting all the calls to that application and we'll monitor those. If you have your laptop out, you can even try to SSH into my instances and do all weird stuff because we're monitoring all of that and we'll get to that. Don't hold back, just try out whatever. Just probably don't do a denial of service attack on that, otherwise we'll have a bad time seeing what is going on. So this is kind of my very, very simple application I'm monitoring. And then to monitor that, I use Cubana. So I have, it's just on a subdomain, Cubana.xiera.wtf. If you go there, it will automatically log you in as a read-only user, so you can even look at some dashboards yourself. Though you'll probably not get all the stuff that I have here. I'll make this slightly larger. I hope this is readable for everybody. So if you have not seen it, this is Cubana. If you have seen different versions of Cubana, I always describe it like that. Cubana 3 was black, 4 was white, 5 was colorful, and this is the upcoming version 6, this is blue. We got rid of the many colors because it was, I've been told, not that great for colorblind people. So the new version is kind of easier to read for colorblind people. And this is just vanilla Cubana. I'm actually running this on a release candidate. So last week we've brought out the release candidate 1. There are some rough edges, but mostly it's working. And since I always want to show the hottest new stuff, that's what I picked for the demo. So this is generally Cubana. So I'm lazy, and you should be lazy too. I didn't build everything myself. We have a lot of dashboards that are pre-built we can just use. So I'll fold that in to save some screen space. And you can go to these dashboards. These are all pre-built dashboards that we have set up for you. And the first thing I want to start kind of very low level on my machine is I want to see the system resources that are being used. It's pretty much on Unix or any Linux, you would use top to see what is going on my system, what is taking up memory, CPU, I/O, all these things. We had something, one of the beats to collect that information, it was called top beat in the beginning because it was doing the same thing top was doing. We've renamed it now to metric beat because it can also collect application metrics, but also the system metrics. So we have our metric beat, and I'm actually interested in the system metrics. So we can just switch to that overview. Every now and then you still get errors in a release candidate. And you can see overall, I have 3 instances. These are the IP addresses of my 3 instances, for example. you can see CPU usage is very low, memory usage is very low, and disk usage is also pretty minimal. So everything good and green. Let's switch to the host overview. Let's see what is going on the host. So here for now, I will say I want to see all the hosts in my system. You can see how many processes are running here, load, network traffic, and over here you can see this is actually the last 15 minutes we're using here. Let me switch on auto refresh. We'll do some stuff and this will automatically refresh as we go along. So I will change or set auto refresh to 5 seconds. So this page will reload every 5 seconds. And it's kind of the dashboard mode where you can see what is actually going on with my system and how is it behaving over time. So you can see we have a pretty stable memory usage and CPU usage. And now I want to do some actual work. So let me switch to an instance. And I will start the Java program. Some of you might say this is kind of the typical Java program because it's allocating memory until it runs in and out of memory exception. It's not doing anything else, so I'm just giving it 512 megabytes of heap, and then I say I have this jar, which is in opt bad, and I've just called it bad.jar, because this will just allocate memory until it dies. And this is a feature now. So you can see this is allocating. It still has memory free, but it will die at some point. And let's switch over to that view, and we should see in the memory usage, so it will collect the information, it will refresh the page every 5 seconds. So after the next refresh, hopefully, we should see a slight jump here. And it's slightly misleading because red, that is the used stuff, and you can see the used part is going down here. So green is what is available, and that is shrinking, and we're using more memory now. And at some point, the Java process will die with an out-of-memory exception, which it just did. This is a feature now. And you can see, OK, now the memory usage is going back. And now you can actually trace that something is going wrong on your system. And you can see something weird happened because it kind of the red stuff grew, and the green memory, the free one, came back. And now you could say, like, I want to dive deeper into that, and I want to build my own visualization. So let's build our own visualization based on the memory usage to see a bit better what is going on. We have by now quite a lot of visualizations. One of the newer ones is called the time series visual builder, so where you can actually build more fine-grained visualizations of what is going on in your system. So by default, it just shows you how many documents do you have in your Elasticsearch nodes overall. But now I want to take a look at the memory usage. So I will call this memory. And I say I don't want a count, I want a sum, and I want that of the field system.memory used bytes. That sounds helpful. And you can already see, OK, yeah, we had this spike here, but it's kind of not a very readable number. So the first thing I want to do here is say, this is not a number, these are actually bytes. I'll switch that over to bytes, and now you can actually see, OK, overall, all my instances, I have 3, were using 1.7 gigabytes of memory. And here something was weird. Like, everything is pretty flat. Only here it just grew from 1.3 gigs to 1.7 at that point in time. And now you might wonder, like, which instance was that, or which process was doing that? So the first thing you can do is you can say, OK, I want to break this up. And I have actually given this a nice readable name, which is called beatName keyword, where I put in the host name. And now you can see this is the breakdown per instance. And all the instances are behaving pretty similar. Only here that spike, that was on the instance front end. This is where I started the bad jar. So this was the one misbehaving, and you can see this spike. And you see, OK, this is not what it should be. And now you could start diving in and see, like, why has there been this spike? Or what is this instance even up to and doing? So that is kind of the system level. But let's get back to our application. So if you see that here, and I hope you've done some requests because we'll need those now, you can just call something like it says, hello world. You can call something with a parameter. You could change that, I don't know, Peter, whatever. It will tell that. We'll actually log that parameter as well. We'll get back to it. And you can also do bad stuff. Like, you can get various 500s, like, OK, something went wrong. Or here, I'm triggering a null pointer exception, which is also kind of common in Java. or you can just get a 404, like, okay, this page doesn't exist. These are just the generic Spring Boot error pages, but it doesn't really matter. We want to see what is even going on our system. So the first part I want to monitor now is the network level. So for that, we have another beat. So we had metrics. Now we want to see the network traffic. And we have a beat called PacketPete. And PacketPete is really there to listen what is happening on the wire and analyzes what is going on. So it understands the protocols, and it will know, okay, this was a request and a response. The protocol was HTTP. The whole thing took 50 milliseconds. You called the URL foobar, and you got a 404 back. And it can extract all of that from the network headers. So I don't need to instrument my application or do anything in particular. I can just listen in on the network traffic to see what is happening. So I'll switch back to the pre-built dashboards. And PacketPete has a generic overview to see what is going on. So if you scroll down a bit here, you will see I only have a web application running now. I don't have any database transactions, caches, or RPC. You could add those and see what is going on there as well. But here, for example, you can see we had 170 and another 177 requests. Those were kind of the top ones when you did some requests. You can see the breakdown of how many requests over time and what was their response time. So most of them were pretty quick, like up to 10 milliseconds. Some took 10 to 20 milliseconds. So the colorful breakdown is kind of like how long did they take. You see the percentiles, like how long did your requests take overall. And if you're interested in the 99th percentile, like some people already had a pretty bad experience here, because you can see somebody was waiting nearly 2 seconds for their request to complete, which might not be a great user experience. You can see stuff like, okay, most of the requests were okay, but we did have some errors. And you can, by the way, switch that color easily, so you can just say, okay, let's make that red. So you can see that more easily, which is, of course, bad if you're red-green colorblind. I hope that is more readable. So you can see there is a difference. We had some errors. Most of the stuff was going well. You can see like from which protocol did we get errors. So we had some DNS errors, but we also had mostly HTTP errors, like up to 76 HTTP errors. And we have a latency histogram. So you can see most of my requests were pretty fast. So it's kind of like somewhere around 2,000 something requests were around 0 milliseconds, but somebody waited up to over 2 seconds for their request to complete. So you might want to dive into that request and try to find it to see how to fix that. But that is just the overview. We have something called flows as well. Flows is who is communicating with who and how much traffic. So here you can actually see my service was pretty idle. I had 200 requests approximately, and then you did some requests, and then suddenly I had more than 1,000 connections over time. And then it dropped off, and then it kind of came back when you did some more requests. You can see like most popular or most active IP addresses, like who is communicating with who, and you can see like which IP addresses are generating how much traffic and how is that going on. And now we can also jump into the HTTP view. So this is actually parsing the HTTP information from the wire. I didn't do anything in particular here. So again, you can see the number of requests. You see overall in the last 15 minutes, we had 1,900 something requests now. Which URLs you hit, and you can see good was the most hit endpoint, which received 515 requests, and all of those were 200s. But some were either 304s or 200s. And bad only gave you 500s. So the color breakdown already shows you that. You can see which errors occurred in your system overall, when did they happen over time, and you can also see which URLs you picked. And I see somebody typed, whatever. I've seen a lot of interesting stuff here. So it depends a bit on the audience. Like, I always say some audiences are very serious, like those are the German ones, for example. They only click on the URLs you have, and they kind of do not deviate from the path you give them. And sometimes some audiences are more playful. Like sometimes I get cuss words in here or feedback. I also had like somebody tried to do a JavaScript injection. So somebody tried to call a URL which is script alert something. We escaped that, so you can try that. You can also try remove and force recursive or something, like we escaped it as well. We don't run that. It's not SQL, so you can also try SQL injections, and we will just collect that, and it would not do anything bad. But yeah, you can collect all of that and see how many requests were hitting that and what was going on. So that was just from the network layer. But we have that information somewhere else as well. So I'm using my Java app, but setting up TLS and handling connections is kind of a pain in Java. So I use a reverse proxy in front of my Java application. So I use Nginx that terminates the TLS connection and that handles kind of, or hands over the traffic to my Java application. By the way, if you called the service, you probably saw that you were only talking HTTPS to it. How did I even see what is going on in my traffic if it's encrypted? That is because I'm taking the traffic behind the reverse proxy. So the reverse proxy terminates TLS, and I actually take a look at the traffic between the Java application and the reverse proxy. Otherwise, I wouldn't see anything. So if everything is encrypted, we cannot break your encryption. This is a feature. You cannot see what's going on in there. And somebody seems to write a script now. Which is totally fine. I guess my service will survive that. OK, somebody is calling good. I'll take this as a good sign. So you have all of this information also in the Nginx access log. So I guess most of you know that. Var log, Nginx access log. So somebody seems to have written a script. Or yeah, selling Alfa Romeo. OK. And we can probably find out who it is by your IP address and browser and stuff. So this is the Nginx access log. And I guess a lot of you know kind of the good old ELK stack, Elasticsearch log/Cubana, where you would collect that file and then you would write the regular expression to parse that, because you have all the relevant pieces in here. So in here, for example, you see you have an IP address, you have a date, you have an HTTP verb, you have the endpoint we called, the response code, how many bytes we sent, who did it. You have all of that information. You would write that regular expression. But at some point, we figured out that nobody wants to write regular expressions. Like, you can do it, but nobody wants to. So we have added something new now called FileBeat modules. So FileBeat is the thing that collects log files. And the FileBeat modules actually know on your operating system, which is Ubuntu 16.04, you want to monitor Nginx. And it knows Nginx is logging to var log Nginx access log. And it knows the default pattern how that log file will look like. So you don't have to do anything anymore. You can just collect that file. And the FileBeat actually knows what to do. Just to give you a very quick idea what you need to do to collect that file. That is the configuration we're using. So we will collect the Java application afterwards. We'll get to that. To collect the Nginx information, all I did was basically I said, this is a FileBeat module, and I want to collect Nginx. And the stack will then figure out where the file is and how to parse it, how to enrich it. So we'll kind of look up the IP address to a geolocation. We will parse the browser to see which are the most common browsers and all of that stuff. We're doing that automatically now. You don't have to do anything but write that line. Yeah, I'm adding some other information to my logs. So this is the instance name, and I'm just throwing some tags in. So you could have different environments, and afterwards you could filter down to a specific environment or where it's running. I'm adding more cloud metadata. I'll show you that in a moment. And this is where I write this out. So this is my Elasticsearch instance, which is running on our cloud service. My username, my password. Don't steal my password, but I'll reset it afterwards. So how does that look like? So we have a pre-built dashboard for that as well, for Nginx. So here we have access and error logs. And this is all happening in the background. So I didn't do anything else. I just said collect Nginx and enrich the information. And you can see we have some geo-IP information. Let's see how good the geo-IP information is, because that varies a lot. Sometimes it's good, sometimes it's bad. Yeah, I'm not sure. Yeah, it's maybe not that good here. Sometimes it's really kind of accurate down to the block, and sometimes it's really not. So you can see some of the requests seem to come from Zagreb, but a lot seems to be like somewhere else in Croatia. I'm not really sure. And somebody, the IP address seems to believe you're here. So it kind of always take geo-IP lookups with a grain of salt, but at least you get the country right and you kind of know where the requests are coming from. Then you see, okay, we did a lot of requests here, like 3,700 was kind of the top time frame. Most of them were 200s. You see the overall errors. You see which URLs were called most of the time. I don't see Alfa Romeo now, which is a pity. And you can see the breakdown, like who is using what operating system or browser. So for example, here we would have, we have Chrome Mobile. So that was, Chrome Mobile was responsible for nearly 12% of the requests. Most of you were on version 61, but somebody was on 60, and then, yeah, even older, 34 on older versions. Or you could see the breakdown of operating systems. So we have Android, we have macOS, we have iOS. So what's your iOS version like? Oh, most of you have already upgraded. Very nice. Some haven't upgraded yet, but that's already the minority. Like 86% here have upgraded to the latest iOS version, and most others don't. This is probably very different to what Android will look like. Anyway, so you could extract all of that information just from the access logs, and you can see how much traffic we sent out. So this is all nice and easy. There isn't hardly any Linux, and there is no Windows Mobile. Recently, I've seen or found a few Windows Mobile phones in there. It's also kind of curious. Other stuff I have just automatically collected from that instance because you might be interested in. So we have syslog, just to see what is going on your instance. And probably not that much happened in the last 15 minutes, so let me switch that to the last 24 hours. And you can see here I was doing a lot of stuff since I was provisioning something after the party. You can see which instances, which processes, so some systemd, some kernel, and you can actually see the log message that we have generated, everything that has been going wrong to syslog, you can collect that. You can see when did you run sudo commands or when did sudo commands fail, just to see like, okay, yeah, I did that, I did an update, I checked out the logs of PacketPete. Those were the sudo commands I ran over the last 12 hours. How they were timely distributed, and luckily I didn't have any errors, so nobody failed to run sudo because that would already be kind of a warning sign. Another interesting thing might be the SSH logs. You have the var log auth log, and there you have all the failed login attempts. And even if you don't monitor it, a lot of people will try to connect to your instances by SSH. So you can see just random scans. It's like, okay, invalid 40 requests here, another 38 invalid requests here. You see, that was me when I did valid requests. And then you can see, okay, these are the usernames people are trying. So a lot of people are trying admin or the domain name or FTP, and root seems to be popular and some others. So whatever makes sense here. And you can see where the requests are coming from. Unsurprisingly, most of them are coming from Russia. Like, that is pretty much what you see most of the time. Sometimes I get a lot of Indian brute force attempts, but yeah, most of the time it's Russia leading here, and you can see. Most other countries are not doing it well. Like, did anybody here try it? We could actually try to filter down to the country now to see if anybody did that. So let's see. We have this new filter here. So even if you don't know anything, you can actually see where are your requests coming from. And let's say country ISO code is, most of them are from Russia or from the Ukraine. Let's go for the Ukraine. So you can filter down then, and you didn't get any, okay, we didn't get any Ukrainian requests here. This is disappointing. Let's see, Russia should work better. Yeah, you can see, these are all the Russian requests you get. So here, here, and here somebody tried to log in. And these are the usernames coming from Russia. So you can just filter down and see what people are trying out in your application. Okay, so that is kind of the system level. Let's get back to our application. I guess you got some 500s. So we had multiple exceptions, and let's see if we can find those. So I'm heading over to the Discover view, which actually shows you the log files which we've collected. And the last 24 hours have probably logged a lot of stuff. So I'm probably killing my browser right now. Let's switch that over to last 15 minutes. Come on. This is the joy of demos. Yeah, you can always try a new window and then Chrome will behave again. So you can see in the last 15 minutes we had nearly 14,000 log entries. Like this was when somebody did a lot of requests. And now we want to see like what is going on. I have added a field application and a few of those requests. So overall we have 13 or 14,000. Like those include the system logs, the Nginx logs, anything that is going on in your system. But I want to filter that down to my Java application. So all the Java logs have this application Java. I'll just filter down to that. And it will be, yeah, it's just 5,000 of those logs are actually Java requests. And then you can open that up and see this is all the stuff we log here. So we have call something good, we have a JSON severity and an info. So we might filter that down to the JSON severity, just the errors. So we have just 10% of our log messages are errors, but those are the ones I'm interested in. So I'll filter down to those to see what errors did we have in our system. Let's open one of these up. That is what you get. We have an entire stack trace, so the joy of Java, where you always have long stack traces. And by the way, we have added some cloud information. I've automatically enriched that in the background as well. So you will know which instance was that, in which region are you running. So I'm running in EU West, so the one in Ireland. That is in the A availability zone, a micro instance. This is where this is running. And this is the stack trace I've generated with that error. By the way, if you can, don't parse your logs. Write them out in a structured way already. So what I'm doing is I have var log, I think I called it apps, and then every application is writing out the JSON file. So since Elasticsearch can store JSON, you can just log out to JSON directly. So this would be one entry here. And while it's not that readable for humans, it's much nicer to parse because you don't have to parse. You can just store it. You see we have a timestamp, we have the severity, we have the service name. If we have a stack trace, the stack trace would be in here as well. It's all nicely parsed already. You don't need to do any hard work or boring work. Avoid boring work. So we have collected that already. And another very nice feature is, so now we know how many Java errors did we have over the last 15 minutes. There were 259. And now I might be interested in how many different stack traces did we have. There's another nice feature of this driver I'm using. It can collect a stack hash, which is this number. Basically what it does is it takes out of the stack trace all the things that change between different requests and just keeps the stuff that is the same in the same stack trace or error and calculates a hash out of that and hashes that. And that is the hash code. So now we could actually visualize how many errors are happening in my system and how often are they appearing, like which one is the most common error. So that is not pre-built, we'll need to build that ourselves. Let's do a vertical bar chart for that. Let's try that. So I have that information in FileBeat. And I say, I want to split up the x-axis on a term. And the term I'm interested in is that hash. So I use that JSON stack hash, and I say, I want the top 15 stack hashes in here. And if you run that, you can see, OK, overall, we have 3 different stack hashes. And one of them is this one here, and then these other 2 ones happen as well. But now you know this is the one you probably want to look at, because this is most of the bad stuff happening in your system is just this one stack hash or stack trace. And these other 2, yeah, they happen too, but they are not as frequent. So you probably are not interested in those. And then you could even break that down further to actually say, let's see, how many, let's break that down into a term again. And then you can filter down, I don't know, if you have a user field, you could just say, give me a specific user field. Since we don't have that, I can just say, I don't know, I have something called a thread, the top 15 threads. You can run that, and then we'll tell you, OK, they are pretty evenly split out over all my threads, but you can see where the exceptions are actually happening. So that's all easy. The other thing you might be interested in is my application up and running? So we had this use case internally where we actually figured out we need something to ping our services and we want to store that. And we've called it Heartbeat, which turned out to be not a great name because there is already a Linux service called Heartbeat, and the two were always fighting when you installed them. So we've now renamed it to Heartbeat Elastic, but the index is still Heartbeat. So to visualize that, we have built another visualization, which will look something like this. So you can see these are all the endpoints I'm pinging. I'm just pinging my front end and my back end application and Elasticsearch and Cubana. So I'm pinging all of these, and everything is up and running right now. And now I can just stop an application. Java or Nginx, which one should we stop? Java? Okay, let's do Java. It's demonized. We have, this is called front end, and we can just stop that. I'll turn on auto refresh again. So every 5 seconds, the pinger is running every 10 seconds and storing the result. And at some point here, it will appear that this service is down. And we're not storing only if it's up or down. We're also storing like how long did it take to reach the service and how long did which part take. So how long does it take to find the service? How long does it take to establish the TCP connection, HTTP, and then how long does the TLS handshake take? So the red thing is, here you can actually see, like, this is the TLS overhead you have in your connections. And then you could actually see, like, if one of them is going up or down, you could see what is actually slowing down in your application. You have a breakdown, like, how long do your requests take? Like, 5 requests were pretty slow down here. They took 350 milliseconds. Okay, and while I was talking, yeah, it's detected, my service is down, and now you could do some alerting or take whatever actions. Now I can start it up again. Since it's a small instance in Java, it will take approximately 20 seconds until the application is up again, but we probably don't want to wait for that now. The next thing you might be interested in is if your application can expose some metrics. How is the application doing? And Spring Boot does that automatically for you. So you can just do a curl for that. We need to authenticate, unfortunately, for that. So I have used admin and secret here. And you can just ping localhost on port 8080 where the Java application is running, and then you can say metrics, for example. So you get that JSON here. I'm collecting the same JSON, and I store it, and then you could visualize whatever is going on here. So you see we're doing garbage collections and how much memory you're using in your application. And you can either do that with REST, or since this is Java, Java has this weird thing called JMX, where you can extract the same information and you don't have to expose it by REST. And I'm collecting the same thing with JMX, and now we can visualize, like, for example, how is my heap doing of my Java application since it's all exposed? Let's quickly build a visualization for that. Oh no, sorry, I didn't want to do a dashboard, I want to do a visualization. So I'm falling back to the time series visual builder again. And this time I say I'm interested in the memory. Or actually, this is the heap. Let's say this is the heap. This is the heap. I'm interested in the sum again. We're collecting the JMX information. I'll just use the JMX information now. There is a plugin to do that called Jolokia to expose it also by HTTP. So I'm doing Jolokia, if I could type it, .metrics, .memory, heap used, usage used. So this is the actual heap used over all my instances. And again, globally, it doesn't make much sense. I want to break that down on the instance now again. So we have beat name. Oh, that's the unreadable one. We want beat name dot keyword. And here you can see, okay, all my heaps were more or less okay. But this thing here, the front-end application that we have stopped, here, there was no heap anymore, which is not surprising since we stopped the Java application. But here you can see, this is my application, this is how it works. And the next thing you might want to do is, you might want to annotate any change you have in your system so you can actually keep track of what is going on. Otherwise, it's very hard to communicate, like somebody changed something and then you're running around the office and scream like, who changed something? I get more 404s or 500s than before. What did you do? And you could store that automatically and see what is going on. So I have I have stored events whenever I change something in my system. Since it's all automated, it stores an event in Elasticsearch to say something changed, and that is part of the events. I can very quickly show you what the events look like. This is just like you throw in a document to document what you have changed. And this would be one of these change events. So you can see, I know that I deployed a Java application to the front-end application to that host, and afterwards the status code was still at 200. This is basically the who am I of the local instance who ran that. And you can now annotate that. So we might be interested in application, host, and user. So what you can do is you can say, I want the variables application, host, and user. And then you can say user deployed application to host. And we'll say we'll make this a bug. And since I haven't deployed in the last 15 minutes while I was up here, let's go for the last 4 hours. And you can see here, Philipp deployed bad to front-end WTF. And you could, like all my Ansible playbooks, write out the same information. So any change you make to your system, you can annotate. And then you see, oh, you changed something, and suddenly, I don't know, the heap grew, or you got more 500s, or stuff changed. You can actually see, okay, who changed what to figure out what is going on in your system. Final thing, you probably want to follow requests in your system. There is something called distributed tracing, where you basically, as soon as a request gets to your application, it gets an ID, and as that request is going through your system, the same ID is kept, and then you can store it, and you can calculate how long did that take. So I'm just finding the slowest 10 requests here, and I saw, okay, that was a slow request here. Let's see what was happening. So we retrieved the fav icon, which took 7 milliseconds. That's not that slow. Let's call something get a slow 500. So you're waiting, you're waiting, you're waiting. Let's get back to Zipkin, which is aggregating that. And you can see, oh, now it took 2-point-something seconds. And you can actually see you called bad, and you can see where you spent your time, because this is a very hard problem in distributed systems. What is slow? This will actually show you down to the method level, like what has been taking up time. And you have integrations into Java, PHP, Ruby, Python, Go, whatever. So you can actually see this was the slow call, and bad was actually very fast. That just took 150 milliseconds, whereas this took 2 seconds overall. So you can actually see which calls took how long and what was their status code. And you can trace that. And these events are, again, stored in Elasticsearch in the background. So it's kind of all in our stack. So we've done a lot of stuff. To finish off quickly, I always compare this kind of a bit to Lego. You have all these building blocks, but you still need to wire them together in the right order. You can use my stuff as a starting point, but you will need to do some kind of assembly in the first place. We've seen a lot of beats like system metrics, network traffic, applications. We saw, is your service up? We got metrics out of the application, and we actually traced requests throughout your system. And that's pretty much it. If you want to give this a try, you can just hit up Cubana, Xera, WTF. It will log you in automatically as a user. It's a dashboard-only mode. You cannot destroy anything, but you can just try out the dashboards yourself and see how they are going. So that should be easy. With that, I have a few stickers over there. If you want some stickers, be quick. Otherwise, I'm always taking a picture with you so I can prove to my colleagues that I've been working today. Otherwise, they always think I'm just on holidays. Can I get everybody on the picture? Let's try. Smile. Awesome. Do we have time for questions? No, no time for questions. Well, find me afterwards for questions. Ping me on Twitter. I hope you learned something. Thanks.